everyone, welcome back. In today's video, we're going to learn how to construct a binary tree from traversals. Now imagine someone gives you just two traversals arrays like preorder and inorder and asks you to rebuild the entire binary tree from them. No original tree, no diagram, just the traversals. At first, that sounds impossible, but using the patterns hidden inside these traversals, we can actually reconstruct the exact binary tree step by step. And in this video, we'll understand the complete reconstruction process visually, learn the recursive logic behind it, and finally look at the reconstruction algorithm as well. So let's get started. Alright, before contrasting trees, we first need to understand what traversal actually means. Traversal simply means visiting every node in tree in a specific order. Now, depending on the order we visit the nodes, we get different traversals. So first, we have preorder traversal. In preorder, we always visit the root first, and then move to the left subtree, and finally the right subtree. For Inorder Traversal, it's a little different. Here we go left, then visit to the root, and then to the right. And finally, we have Postorder Traversal. In Postorder, the root is visited last. So we complete the left subtree and the right subtree and only then visit the root. These traversal patterns are extremely important because later they help us reconstruct the original tree. Alright, now let's see how the same tree gives different traversal outputs. First, let's look at preorder traversal. So in preorder, we always start from the root node first. Here the root is A. After visiting A, we move to the left subtree, so we visit B. Then B, we can go left first, which takes us to the D. Once D is done, we come back and visit E. And finally, after completing the left side, we move to the right subtree and visit C. So the preorder traversal becomes A, B, D, E, C. Now let's move to the Inorder Traversal. Here we first go completely left before visiting the root. So we start from D and then move back to B, then E. After visiting the left subtree, we visit A. And finally C. So in order becomes D, B, E, A, C. Now for Postorder Traversal, this time root comes last. So we first complete the left subtree, D, E, B, then the right subtree, C, and then finally the root. So the Postorder Traversal becomes D, E, B, C, A. Now, this is the main idea behind the entire reconstruction process. The preorder traversal helps us identify the root node immediately. Why? Because preorder always starts with the root. So whenever we check preorder, the very first element tells us the current root. Now, Inorder helps us split the tree. For example, here's the root is A. And then we find A inside Inorder Traversal. Everything on the left side belongs to the left subtree. And everything on the right side belongs to the right subtree. So the preorder tells us who the root is, while Inorder tells us how the tree is divided. And combining those two ideas allow us to reconstruct the full tree. Alright, now let's actually solve a complete example. Suppose we given these two traversals. The preorder traversal is A, B, D, E, C. And Inorder Traversal is D, B, E, A, C. Our goal is to rebuild the original binary tree from these two arrays. So let's do it step by step. The first step is always finding the root. So let's look at preorder traversal first. Remember, in preorder, first element is always the root. And here's the first element is A. So immediately we know that A is the root of the tree. Now the next step is finding A inside Inorder Traversal. Here it is. Now notice what happens. Everything on the left side of A, D, B, E, belongs to the left subtree. And everything on the right side, C, belongs to the right subtree. So just from this single step, you already know how the tree is divided. Alright, now let's build the left subtree. So after A, the next element in preorder is B. That means B becomes the root of the left subtree. Now let's look at B inside the Inorder left segment. Here we can say B right in the middle, so everything left of B becomes the left child, and everything right of the B becomes the right child. That means D becomes the left child of B, and E becomes the right child of B. And now left subtree is complete. Notice how we are repeating the exact same process again. Find root, split in order with left and right. That repeating pattern is exactly why recursion works so well here. Now let's finish the right subtree. At this point, the only remaining node in preorder is C. So C becomes the right child of A. And since the inorder right segment also contains only C, there are no further splits needed. So now the entire binary tree is reconstructed successfully. Okay, now that we understand the visual process, let's connect it to the actual algorithm. The reconstruction process follows four main steps. First, pick the root from the preorder. Then locate that root inside the inorder traversal. Next, split inorder into left and right subtrees. And finally, repeat the same process recursively for both sides. Now if we look at the pseudocode below, we can see the same logic implemented step by step. First, we check if the traversal is empty. If it is, we simply return null. Otherwise, we create the root node using the first preorder element. Then we find the root inside the inorder traversal. After that, we split inorder into left and right parts. And finally, we recursively build the left subtree and right subtree. So the recursion keeps breaking tree into smaller subtrees until everything is constructed. Alright, so let's quickly recap what we learned today. Preorder traversals helps us identify the root nodes. Inorder traversal helps us separate the left and right subtrees. And by repeatedly applying the same logic recursively, we can construct the entire binary tree. Once you understand this visually, the recursion becomes much easier to understand. And honestly, this is one of the most important tree concepts in DSA interviews and coding problems. So, if this video helped you to understand binary tree reconstruction clearly, make sure to like this video and subscribe for more beginner-friendly DSA explanations. Thanks for watching and I'll see you in the next video. Peace.